Right, everyone in? Anyone need to come?
I'm here.
Benny is there, Matthew is there,
Yep, think good. Yep, I'm here.
Aftab is there, Vivek is there, Meets, Pete. Okay. Thanks, Pete. Okay. So now Redux Saga. So Redux Saga is a middleware, basically how you handle asynchronous operations in React applications. Okay, how we handle asynchronous operations in React applications. See, when you look at the problem, right? Um, so let me show this. Just give me a second. Right. So when you look at the fundamental problem, if you take a normal action, a synchronous action, if you take a normal synchronous action, right, it starts at one point and then it proceeds in its flow, and then finally once it is completed you have the action object available and you return the action object which will be dispatched by the action dispatcher. Right, you return the action object which will be dispatched by the action dispatcher. But in the case of an async operation, you start at one point and then the data is not immediately available, so you make a call to somewhere, now wait for it to complete, and then you get this, and then you perform one more operation, and you initiate one more async operation, and then the data will not be available right away, and then after some time the data will come, and then you have to perform an operation, right? So how will you handle these kind of scenarios? Why? Because when you initiate the operation, you don't wait for the response to come, you move on. You move on, right? Async operations, you don't wait for the response to come, you move on. So if you move on, then how will I perform this sequencing? How will I orchestrate my operations one after another? Right, so we solve this problem with the help of promises. So every async operation returns a promise, and using the promise you can what do you call, you wait for the promise to resolve. When the promise is resolved, you continue with it, and then you perform another operation which will in turn result in another promise, and you, when the promise is resolved, you take the result and move on. Right, so we solve the async operation with the help of promises. But the problem with promises is you need to say await, or then you have to do that. Or the other thing is, if you have to um, uh, coordinate between multiple promises, you are performing two async operations and you want to wait for both the async operations to complete, and when they complete you want to perform one more operation, right? You want to perform one more operation. So how will you handle these kind of scenarios? So in the case of promises, you have to write the logic to handle all these kind of scenarios, right? But to handle these advanced scenarios, what we have is another feature, another middleware called Redux Saga. Okay, the idea behind Redux Saga is a saga is an independently runnable operation. Okay, independently runnable operation. So what we do is, whatever async operation that we want to perform, right? What we do is, whatever async operation we want to perform, we will write them as instructions. We say do this. Okay, we will write them as instructions. Do this, do this, do this. Wait for the data to come. When the data comes, do this. We will write them as instructions and give these instructions to a Saga engine. Give these instructions to a Saga engine, and the Saga engine will understand these instructions and execute them one after another. right? Now, how will it execute them one after another if it is async? How it will execute them one after another if it is async? Because if you are going to write all the operations, all the instructions in one single function, let's assume all the instructions in one single function, how will the Saga engine execute all these instructions one after another, right? So Saga exploits ES6 feature called generators, right? Saga exploits an ES6 feature called generators. So what is the idea behind generators? Generator is a beautiful concept. Generator allows you to suspend and resume the execution of a function. Okay, generators allow you to suspend and resume the execution of a function. How can I suspend and resume the execution of a function? Let's say, for example, function numbers generator. I'm going to create a simple numbers generator, and a generator function, because it is not like a regular function where you invoke it in one shot. You suspend it and then resume it, execute, you initiate it, suspend it, and then resume it, suspend it and then resume it, suspend it and then resume it. So because this function behavior is completely different from how you execute regular functions, right? There is a special syntax using which you inform the runtime that this is a generator function by prefixing the function with an asterisk. Okay, the function name with an asterisk. So this, when you prefix the function name with an asterisk, it means that it is a generator function. Okay, very good. Now what do I do? In a normal function, you will say return, right? You will use the return keyword. In a normal function, you will use the return keyword. Now, in a generator function, if you want multiple values to be returned one after another, right? You don't use return keyword. Instead, you use the yield keyword. Instead, we use the yield keyword. So what do I do in yield? Yield with the result. So you can say yield 10 and then yield 20 and then yield 30 and then yield 40, right? Like that, so you can yield what, how many ever you want to yield, you can yield. And then finally, when you get the final result, you can say return 50, right? The last one, the final result, you can say return the last result. Okay, very good. Now I got the generator. Now how will I get one value at a time? How will I get one value at a time, right? So what you can do, let us get the generator object. So where gen equal to call numbers generator. So this gives you an object, and this object has a method called next. Okay, this object has a method called next. Watch this. So gen dot next, call this. It returns an object with the first value, and then the done says false, which means what? There are more values. Did I unmute it? Am I? Yeah, I have unmuted. All right. So when I call gen.next, it returns an object with one value. Okay, very good. And then what can I do? Call gen.next again. You see the done is false. It means what? There are more values to return. So you call gen.next. You get what? Value 20. The next yielded result, done is false. And then once again gen.next, value 30, done is false. Call it again, value 40, done is false. Now call it again, you get value 50 and done is true. Done is true. Make sense? Right? So this is a generator function. This is a generator function. Now, Redux Saga exploits this generator. How does it exploit this generator? Very simple. What we do here, okay, what we do here, we combine the generator with the promise. We combine the generator with the It will yield one promise, promise 1. Okay, and then the subsequent async operation, it will yield another promise, promise 2. Subsequent is a operation, it will yield another promise, promise 3. Now, what the Saga engine will do, the Saga engine will call, give me the next one. Give me the next one. It will get the first promise. Wait for the promise to resolve. Once the promise is resolved, then it will call the next promise, yield, give me the next one, right? Generator dot next, give me the next one. And then wait for that promise to resolve. And when that promise is resolved, it will call the next one, right? So the Saga engine will take care of calling the generator function. This is your Saga. What you write is your Saga. So you write your Saga, and that will have multiple async operations performed, each of them yielding a promise. And what the Saga engine will do, the Saga engine will take care of orchestrating each of these operations one after another using this logic. Make sense? Hello?
Yep. Yep.
Okay. Right. So basically all you are doing is you are yielding multiple promises from one Saga, and the Saga engine will ensure that all these promises are orchestrated, sequenced in a way you want them to be sequenced. And to assist you with this operation, what kind of operation? Sometimes you might want to wait for an async operation to complete. Sometimes you might want to process the result of an async operation, right? Sometimes you might want to process the result of an async operation. Sometimes you want to make an external call to an API to get the data, right? So in order to perform all these various async operations, right, Saga gives you what you call as effects. EFF ETECTS. Saga gives you what you call as an effects. Okay, so the effects are there to assist you with orchestrating the async operations. For example, so I'll tell you what are all the effects. So there is one effect called take. There is one effect called take. So what take will do, take will wait for an action to be dispatched. Take will wait for an action to be dispatched. It will simply wait. So when you create a Saga, you will give it to the Saga engine and say, boss, run, you process this, right? But when the Saga engine processes it, right, you tell you using your Saga, you communicate that wait, process this only when an action is dispatched. You are supposed to execute this only when an action is dispatched. How will you communicate that? It has a effect called take, using which you can communicate that wait for this action to be dispatched, and only when this action is dispatched, you move on with the subsequent operation. What can the subsequent operation be? Let's say I have some data and I want to dispatch an action from here because I have done some processing. I want to dispatch an action from here. So how can I dispatch an action from here? You use put. So put is to dispatch an action from here. Take means you wait for an action to be dispatched, and only when an action is dispatched, you continue processing. And put means you dispatch an action from here. So from the Saga, you dispatch an action, right? And remember, these are executed in future by the Saga engine. These are executed in future by the Saga engine, right? And let's say you want to communicate, you want a method to be invoked, you want an object called method to be invoked. Do you want the method to be invoked right away, or do you want the method to be invoked in future when the Saga engine executes these two lines of code? We want the method to be executed in future when the Saga engine executes these lines of code, right? So what do? If I want a method call to happen, then I can use the call effect. I can use the call effect, and there is an apply effect. So using the apply effect, you can retain the execution invocation context, more or less the same like JavaScript apply method, right? And then you want to process all the what do you call uh, actions, right? So there is one called take every. There is one effect called take every. You want to start processing only until a particular what do you call action is dispatched. So there is one effect called take until. There is one effect called take until. So like this, you have a lot of effects using which you can orchestrate your async operations. You can orchestrate your async operations. So this is the idea behind sagas. So your saga is nothing but a generator function which will yield the result of these effects, all these effects, and your saga engine will orchestrate the async operations in the sequence in which you have defined in your generator function, which is what we call as your saga. Okay, so I'll show you a simple example. Just give me a second. Give me 1 second. So give me a minute, it is taking some time. My network is slow all of a sudden. Okay, so okay, so this is a quick example that I could find, and what I will do, I will update the existing our application with the Saga and then share it uh, for now. Okay, so this application is using Sagas for communicating to the server and fetching data. Okay, for communicating to the server and fetching data. So basically, the UI is very simple. The UI has earthquakes list of earthquakes. So the UI has a refresh link, and when you click the refresh link, it has to get the data on the server and then display it here. That's all, nothing else. Okay, so it has to get the data and display it here. Now, how are we doing it? How are we doing it? So let us look at the how it is organized internally. Okay. So first and foremost, we want to get the data. We want to get the data. Sorry, we want to dispatch an action that will get the data, that will initiate a call to the server and fetch the data, right? So where are we initiating it? We are initiating it from the application. So if you look at the components, and from the components we have quacks.js, and here when I click the button, I am initiating an action called refresh quacks. That's all, right? When I click the link, I am initiating an action called refresh quicks. So, and when I initiate an action, so what all it returns. So if you look at the what is it, actions, all it does is when you call the action, it calls store.dispatch that particular action. You are simply dispatching an action. So from the UI, you are dispatching an action. So when you're dispatching an action, what is happening? Who is processing it, right? The Saga engine will process it. The Saga engine will process it. Where is the engine coming in? The engine is added as a part of your store. Okay, so the middleware, the Saga engine is available as a middleware. So we import the create Saga middleware from Redux Saga, and we add it to our middleware chain in when we are creating the store. We add it to our middleware chain when we are creating the store. Okay, so once we add it, right, what are all the sagas to execute? What are all the sagas to execute? So we have a couple of sagas. Okay, so what are the sagas? So let us look at the action. We want someone to handle this action. What action? From the UI, we were dispatching an action, isn't it? We were dispatching an action called refresh quicks. So we want someone to handle this particular action. Okay, who will handle this? This action will be handled by a saga. Which saga? Let us look at it. So under the modules my sagas, we have a few sagas. Now look at this. Look at this. So we have an generator function which is called watch refresh quacks. Okay, watch refresh quacks. And here what we are doing, it's a generator function. So we have to yield, and we are saying, hey boss, whenever there is an action that is dispatched by name refresh quacks, whenever, every time, take every time an action is dispatched with the name refresh quacks, handle that particular action using this saga, right? Handle that particular action using this saga. Okay, very good. So what am I doing in this particular saga? So this is also a generator function. So what am I doing there? When this saga is processed, I want to talk to the server to get the data. Do I want to do it right away? No, I don't want to do it right away. When the saga is processed by the saga engine, I want it to happen, right? So how do I do that? I am using the call effect. I'm using the call effect to invoke this particular function, right? And what this will return? This will return a promise. So you wait for the promise to resolve and get the response. Once you get the response, what do you want to do? This data has to reach the store. This data has to reach the store so that the component can display this particular data. So how will I carry this data to the store? From here I have to dispatch an action. Right, from here I have to dispatch an action. Okay, now what is the helper function in Redux Saga to dispatch an action? I told you earlier, put, right? There is put. So what I do, I once again, this is every helper has to be used with an yield. So call is used with an yield, put is used with an yield, take every is used with an yield, right? So every effect that you are using, every Redux Saga effect that you are using, it has to be used with an yield. And here we say yield put, right? Which means what? Dispatch this particular action. Please, you dispatch this particular action. And now, otherwise I throw an error. Okay, very good. Now who will process this? Who will process this? Our reducer will process this. So if you go to the reducer, what is the action? The action is set quacks. So in our reducer, we have an action type that says set quacks, and here we simply say return state dot blah blah blah. So basically we are updating the current state, and when we update the current state, automatically it will be rendered in the UI, right? right? So this is one saga that we have written. This is one saga that we have written. So in this saga, what are we doing? We are watching for this action called refresh quacks, and when this action is dispatched, we want to handle that particular action like this. So here I am making one more call, and when the response comes, I am dispatching one more action, which will be processed by the reducer, So this is what we are doing. A very basic example for the Redux saga. Okay. Now, what can happen? I might want to add. So in our case, right? What can happen? We might want to get the bugs. We can have one handle for any request for getting the bugs. We might have save bug. We might want to have one more action for remove bug, right? So we can have all these defined in the saga, and for each of them we can have a handle. So in that handle we will perform the respective operation, and then once the operation is performed, we will get the data and then dispatch an action using the put effect, and that will automatically be processed by the reducer, which will update the data in the store. And once that gets updated, automatically the UI will display. Make sense? Hello?
Yep. Makes sense.
Yep. Yes.
Right now, why do I have to use this? Why can't I use something else? Why do I have to use this? The idea is very simple. Because you are yielding your async operations here, you can orchestrate if there are multiple async operations that need to be performed. For example, you want to make one call to one service, get the data. Based on that, you want to make another call to another service, get that particular data, and then you want to consolidate them, and then you want that data to reach the store, right? Those kind of orchestrations among the async operations can be performed here. So what when we are using the effects, right? When we are using the effects offered by Redux Saga, you are not actually executing. So when this line of code is executed, you are not actually executing. When this line of code is executed, you are not actually executing this function. You are only giving the instruction to the Saga engine saying that, hey boss, when you process this, I want you to call this particular function. And when the result comes, you give the response to this particular object and then proceed executing this. Right? So these are just instructions. These are not actual code which will be executed when this function is executed. When the function is executed, the Saga engine, which is your middleware, will call this function. That is why it is a generator function. It will call the middleware, it will call your Saga function, and it will ask, hey, give me the next async operation. Give me the next async operation. Give me the next async operation. So it will keep calling the async operation, and it will perform the async operation, and it will orchestrate all these async operations one after another. So instead of you writing the logic to orchestrate all the async operations, you are using a different engine to orchestrate all the async operations, and your instructions to that engine is what we call as the effects, the Saga effects. Okay, so I will check in this code. You take this code, have a look at it. But later, what I will do by end of today, I will implement this application. So whatever application that we wrote, right, the bug tracker application, I will implement that application using Redux Saga. Is that okay? We won't have time to implement it now, so I will implement it by end of today. And after the class, I'm going to take a nap, and after that, I will implement it, and probably by tomorrow morning you will have it in the GitHub repository. You can take it and have a look at it. Is that okay?
Yep, that's fine.
Yep. Good. Sounds good.
Right. Okay. You got an idea, right?
Mm-hmm.
Hello.
Yeah. Yes. Yes.
Okay. Okay. All right. Good. All right. Now the next one is how do you use TypeScript? Right? How do you use TypeScript? So it's actually first, if you understand the role of TypeScript, everything
Yes.
will be. Yep.
Is there just a quick question on the Saga and the reducer? I'll post it in the chat, but it's if since the Saga is listening to the refresh quakes, what would happen if you had your reducer listening to that as well?
What will happen if you have your reducer listening to that as well? Did you if you look at the sequence of the middleware, right? Your middleware one second. So this is 201. Okay, so if you look at the sequence of the middleware, you have middleware 1, middleware 2, middleware 3, and the final is your dispatch, store.dispatch. Okay, so your actions are sent through your middlewares, and then the last one is your store.dispatch.
Yep.
Makes sense? So if you have an action that is being processed by the Saga middleware, it will be processed first and then it will reach the last middleware. And if you are responding to that in the reducer as well, that will also be picked up. But you need to remember this sequence.
Do the how does it know which order to do the middlewares in?
Because middlewares are composed in a particular order, right? So if you look at the store, you are composing the middleware. Your actions will be sent in this particular order. Your actions will be sent in this particular order. I'll do this. So watch this. So you have the logger, and here let me put an console.log. So console.log logger middleware, and then let me take this, save this, go to the async middleware and console.log async middleware, and then the next one is promise middleware, and we'll add it in the promise middleware. Right, save this, and then in the promise middleware I will say what is next. Watch this. So I'll say console.log. So in promise middleware, what is next? Next is comma next. Okay, so in our store we are composing them as first logger and then async and then promise. Okay, now let me run this. The application is running. Am I using the logger middleware? No, I'm using the logger. I'm not using the logger middleware. I will use the logger middleware. Okay, save this. Now, logger is defined not used. That's okay. Now let us go to our application, and I will say 3 up. Okay, so first is the logger middleware, and then comes first is the logger middleware, and then comes the async middleware, and then comes your promise middleware. And in the promise middleware, what is next? Next is the dispatch function. Is that clear?
Cool.
This is the store.dispatch. Yeah. Okay, so this is number 1. Number 2 is you see, actually, sorry, one second. I was about to say something and I forgot. Here is it. You can have the same actions being responded to by multiple reducers. By default, every time an action is dispatched, what will happen? That action will be sent through all the reducers. That action will be sent through all the reducers. by default, whenever you dispatch an action, that action will be sent through all the reducers. If you have 50 reducers, that action will be sent through all the reducers. So it is your responsibility to ensure that the action names are unique in all the reducers. If you want the action to be processed by only one reducer, but there are scenarios where you want the action to be processed by one or more reducers, in which case you can consciously use the action name in one or more reducers. But you need to remember that your action will be sent through all the reducers in order for it to be processed. Okay, so that is something that you need to keep in mind. Okay, shall I move on? Any other questions? Guys, shall I move on?
Yes.
Okay. So TypeScript. So what is the role of TypeScript here? Okay. So TypeScript is a superset of JavaScript. Okay. TypeScript is a superset of JavaScript. So why do we need a superset? Why do we need a superset? Okay. So I'll tell you the origin of TypeScript. Then you can better understand why you use it. So JavaScript is by default loosely typed. Right? So what do you mean by loosely typed? In C#, because you are all .NET developers in C#, let's say I declare a variable int x equal to 10, and within the scope of that particular variable, within that particular variable scope, can I assign x equal to abc within quotes? I cannot. Right? I cannot x equal to abc within quotes. It will throw an error. My compiler will throw an error saying that, hey boss, you have declared the variable of type integer, but you are assigning a string value. Right? It will throw an error. Whereas JavaScript is loosely typed. So how do you declare a variable? You say var. When you say var, this is not the C# var. This is JavaScript var. So in C#, it is inherently typed local variable, implicitly typed local variable, right? So that the compiler detects what is the type of the variable and declares the variable of that particular type. Whereas here, there is no compiler. So when you declare a variable as var, all you convey is you want a variable x. That's all. You want a variable x. If you try to convey that you want a variable x to hold a number value, right? Your compiler, your runtime will say, I don't care. You want a variable, I'll give you a variable, and you can assign a number, you can assign a string within the same scope. In the next line itself, you can assign a string, you can assign a boolean value, you can assign an object, you can assign whatnot, right? So this is the nature of JavaScript. And when you are building complex applications, enterprise-wide applications, this can prove to be a little difficult to manage. Right? This can prove to be a little difficult to manage. Why? Very simple. Think about it. Let's say we have a function to add two numbers. Right? Let's say we have a function to add two numbers, return x plus y. And as an author, you expect this function to be invoked only with two numbers. As an author, you expect this function to be invoked with only with two numbers. Now, but if you write this function, the users of your API can invoke it with numbers, can invoke it with strings, can invoke it with objects, can invoke it with functions, but you don't want that, right? So what you have to do, you have to explicitly write the logic. You have to say if type of x is equal to is not equal to number, or type of y is not equal to number, then you throw an error, right? Throw new error. What is the error? Invalid arguments error. Otherwise, you go about processing it. right? So you have to explicitly write this logic if you want your function to be used in a very strict manner, that the function should take only 2 numbers. But when you are building enterprise applications, you cannot type this again and again and again for every API that you create, right? So that is where TypeScript came into existence. So what TypeScript did, the name TypeScript, right? The name TypeScript means associate type information in JavaScript. That is how it started. Associate type information in JavaScript. How do I associate type information in JavaScript? When you declare a variable, you say where x equal to 10, and in TypeScript you say where x colon number equal to 10. In JavaScript, you write a function add of x comma y and return x plus y. In TypeScript, you write the same function as x colon number, y colon number, and return a number, right? So this is your TypeScript version of your JavaScript code. Okay, very good. But can I take this and give it to the browser? Can I take it and give it to the browser as it is? So if I take it and give it to the browser, right, the browser will complain. The browser will say, hey boss, what is this colon number? I don't know what you're talking about. Why? Because the browser supports only JavaScript. It doesn't support TypeScript. It supports only JavaScript. So what am I supposed to do? What I have to do, I have to send this code to a compiler. I have to send this code to a compiler, TypeScript compiler. And then what the TypeScript compiler will do, the TypeScript compiler will take this and then remove all colon number, and give you just a plain simple valid JavaScript function, which you can take it and send it to the browser for execution. Now the question is, why should I write it like this and then send it to the compiler, and the compiler will remove all colon number and give me the actual JavaScript function, and I have to send it to the browser? Instead, why can't I write it as it is? Why do I have to write it like this and then send it to the compiler to generate this? Why can't I directly write it like this? The benefit of writing this is, suppose in your application, someone else is invoking this function with a string, right? The compiler will validate that call. He will say, hey boss, the function is defined to take 2 numbers as arguments, but you are returning a string. I'm sorry, you are invoking it with a string value. So this is a wrong usage of the function, so you cannot do it. You will get this error at the compilation time. In the absence of the TypeScript compiler, you will get the error only at runtime. Make sense? Right? So we are using TypeScript for this compilation time type check. So is the variable, is the arguments passed to the right argument, is the type of the argument is the what is expected, is the type of the value assigned to the variable is what is expected, right? So this is how it started, associating type information with your JavaScript code. So this is how it started, so that a lot of errors can be caught at the compilation time itself. You don't have to wait until they are thrown at runtime, right? So this is how it all started. But then subsequently, what they realized that, so this is even before ES6 days. So they realized that JavaScript lacks a lot of features. For example, arrow functions are not there, default arguments are not there, class support is not there, interfaces, concept of interfaces is not there, support for generics is not there, right? So what they did, they added all these features as a part of the TypeScript itself, and they said, hey, you use a class, TypeScript offered a class, anyway we have a compiler, we will exploit the compiler to convert the class into a constructor function in JavaScript. So TypeScript became a high-level language to write JavaScript. The way we use C# to write IL code, right? We can directly write code in IL, intermediate language, right? But we don't do that. We write our code application in C# and then we give it to the C# compiler. What the C# compiler does, it converts it into IL. So similarly, we started using enhanced the capabilities of TypeScript by adding more and more language features, by adding classes support, by adding arrow function support, by adding interfaces, support for interfaces, enums, generics, etc., etc., etc. We started adding all these features, but ultimately when they are compiled, they will be compiled as JavaScript. Okay, and most of these features were aimed at one thing. What is it? To create a proper type safe JavaScript code. To create proper type safe JavaScript code. So this is how TypeScript started, and then over a period of time, a lot of features that were introduced in TypeScript made into ES6 itself. Okay, the classes support for classes was added in ES6 itself. Support for arrow functions was added in ES6 itself. So a lot of such language features made it into the ES6, and then there are also some of the features that are available only for TypeScript, like for example, concept of interfaces, right? Concept of enums, public private access modifiers. So access modifiers are there in TypeScript, but they are not there in JavaScript. But if JavaScript doesn't support, how will our public private work? Public private is not happening, is not considered at runtime. At runtime, when the code is compiled, it will not have public or private. During compilation time, if you are using a private member, then your compiler will throw an error. Your compiler will throw an error, right? So these compilation type check, right? Validating your data at the compilation time is the value addition that TypeScript brings to the table. Okay, so this is the use of TypeScript, especially when you are building enterprise applications. Then dealing with APIs with the specific type, right, makes your job a lot more easier. You can catch a lot of exceptions at the compilation time rather than waiting for it to occur at runtime. Okay, so this is how it started. And now if you are going to write your code in TypeScript, your application setup also has to be supporting TypeScript. You need to have the TypeScript compiler, and you need to write your code in TypeScript, and then that code need to be compiled into JavaScript, and that has to be executed by the browser, right? Fortunately, we don't have to do a lot of things to have that. We have a switch in Create React App that can do the job for us. So it is npx create react app, okay, 07 TypeScript React app, okay, hyphen template TypeScript. Okay, I'm saying hyphen template TypeScript. So this switch will generate the application with TypeScript support. Done. Okay, so it has generated the application with TypeScript support. Now let us look at it. So here it is, the application number 5, number 6, number 7, TS app, and here source, you see here app dot, the extension is what? TSX. It is not JSX, it is TSX. The extension is TSX. Okay, index.tsx. So here there is nothing that is TypeScript specific, but we can add TypeScript data. For example, we will say import asterisk as React from React, and here what is this? This is a functional component, right? This is a functional component. So how will I define this? What is this? How will I define this? I'll say constant app is of type React dot functional component is equal to function app. So basically here I'm saying that the app is of type React dot functional component. You see, app is of type React dot functional component, and then you can define what is the component, and it will automatically pick it up from there. Okay, so like this, you can define props, you can define the state, you can define the action type. So all these things you can define as a part of your application. So it makes your JavaScript code a lot more easy to maintain in the long run. For example, when you are creating a reducer, action, right? When you are creating an action, you can define what should be the action type. So you can say interface, or add bug, or save bug, and here you can say what should be the type, and then what should be the data, what should be the payload, and this you can say this is of type string. And as a matter of fact, you can also define this. So you can say type save underscore bug equal to save underscore bug. Okay, so this is interface save bug action, and here you can say this is not any string, this has to be type of save underscore bug, right? Type of save underscore bug. Yeah, right. Okay, so there is a way, I'll tell you. So there is a way by which you can define the type of that particular member as type, and then you can define what should be the payload. Payload should be an object of type something, or you can say save bug action payload. You can define that. So you can say interface save underscore bug underscore action underscore payload. What should the payload contain? Right? What should be the payload contain? So the payload should contain an object of type ID, which is a number, an object of type string name, right, which is a string. And once you define this payload type, what you can do? You can say payload should be of type the save bug action payload, save bug action payload. So you can define this. Right, for now I'm making it as a string, but you can define this. And then when you are defining, when you are creating an actual action object, so you say constant save bug action, and when you are creating the actual action object, you can say this has to be of type save bug action and equal to an object. Is that clear? Now immediately it throws an error. You see why? Because this doesn't have the type. This doesn't have the type. So it says save bug action is declared, but it is never used. Type is missing. What are the missing? Type and payload are missing. So you define the type. I define the type and say save underscore bug. And then what is the payload? The payload should be an object. So if you just have an object, it will throw an error. It will say that the payload expectation is not met. So what the payload should be? The payload should be an object with ID as 0 and name as blah blah blah, right? Now you see all the errors are gone. So every aspect of your application can be made type safe. Your actions can be made type safe, your reducers can be made type safe, your what do you call components can be made type safe. So every aspect of your application can be made type safe. So this is the idea about TypeScript. Now you can define interfaces, you can have generics also, right? You can have generics. So what are generics? For example, for this functional component, you expect some props, and the props must have what do you call some data. The props must have some data. Okay, so you can say this has to be of my component prop. This has to be of type my component prop. So what is my component prop? Let us define it. So interface my component prop, and this, let's say this has x is of type number and y is of type number, right? X is of type number and y is of type number, and here we will receive the prop. So we'll say we receive the props, and then we are going to use it. Now when we are using it, where are we using it? So in our index.tsx, you see that it throws an error. Why? Because we have mentioned that the app as a component must take a props with X and Y, right? It should take, it has to take a prop as X and Y. But in the index.tsx, where we are using the app component, we are not passing any prop. We are not passing any prop. So that is why it is throwing an error, right? So if you say X equal to 10 and Y equal to 20, okay, now we are passing the props, that error is gone. That error is gone. So like this, you can make all every aspect of your application type safe. Is that clear?
Yep.
Okay, so this is about TypeScript, and you take an existing application that is built using TypeScript, you will be able to understand. As I said, you will define the action types, you will define the reducer parameters, you will define the component props, you will define the state, right? The store state using the TypeScript interface signature, so that you cannot assign any other type of value in your application, right? So you can catch a lot of errors at the compilation time instead of catching them at the runtime. So this is the use of TypeScript. Any questions?
All good here.
Okay. Right. So how do you create a build? Right. As I said, your application setup has the build configured. So all we have to do is cd 07 ts tab, and then run the command yarn build. So when you run the command yarn build, it will automatically create a build for your application, which you can simply copy and paste wherever you want to deploy. Right. So now this TypeScript throws an error. What is it? Yeah, type is missing. Right. I didn't save this. I didn't save this. See now I got the error during the build process itself. One is I'll get the error at the in my editor itself. The other one is the error will be thrown during the build process itself. Okay, so create the build, and the build is created. Now simply copy and paste these files in the build folder into the server. You are good to go. Yarn build. That's all. Now someone asked about how to localize the build setup for our application. Right? How to localize the build setup for our application.
Yeah.
So how do you do that? Very simple. You run yarn eject. So if you run yarn eject, it will ask, are you sure? Because this is so this says you cannot undo this. Right? This is permanent. You cannot undo this. And now you say yes. Okay, so I did not check in the files, so that is why it is throwing an error. So let me check in all those files. Check in the files, and then say yarn eject. Say yes. Done. Okay. So now if you look at the application folder, you'll find that there is a config folder added and the scripts folder added. The config is where the Webpack configuration is being maintained, right? And the scripts is where you have the start and build script code maintained. So if you go to the scripts tag, this is where the start and build scripts are maintained. The code for starting your server, right? That's all here.
Right. Okay. So you can just change it and then commit it, and then
If you want, you can change it.
start
Yes.
as usual, and you use this one. Okay.
That's right. That's right. As a matter of fact, your package.json file is also changed. So if you look at the package.json file now, it has a lot more dependencies. And then your start script is not saying React script start anymore. It is node scripts / start.js.
Okay. Good.
All right. I am done. Any questions?
Nope. Not for me.
Yep, nothing from me as well.
Okay. Is understanding your code base is easy now in the past 2 days when you go through the code?
Our code base is not easy to understand at times.
Okay.
But this is very clear what we're doing.
Some improvement.
Yeah.
Is there some improvement?
It gives us the direction, right? I think it gives us the right path to look into things.
Okay.
Yeah.
Excellent. So this is my contact details. So I am reachable on dkmagesh77@gmail.com, and then this is my phone number. So +91 9019 11221. Okay, so please feel free to reach out to me in case I can be of any help, and I will check in the code with the Saga implementation of the application. I will check in the code so you can have a look at it, and if you want any clarifications on that code, I'll be more than happy to assist. So we can meet again sometime like this for half an hour or 1 hour, and then I'll take you through that code.
Are you gonna keep that repo there for a while, or you like?
Yes. It'll be there. It'll be there forever. So
Okay,
don't
cool.
worry.
Thank you.
Right. And Benny, by any chance, can I get the video recording?
Yeah. Hello. Yeah. Our manager, Joshua, he's going to put all those videos in a single folder. So when he got it ready, I will ask him to send you the share link.
That will be great. Thank you so much.
Yeah.
Right. Okay. So thanks again, and I hope the 3 days were useful. And feel free to let me know in case I can be of any help. I'll be more than happy to assist.
Thanks, Magesh. That's been really helpful.
Great.
Yep. Thanks
Thank you very much.
Bye.
Thank you. Thank you.